Salam everyone! In the last episode, we explored two metrics, variance and covariance. Today, we'll dive into another key statistical measure used in time series analysis, correlation, and we'll explore its relationship with covariance. Before we dive in, just a quick reminder. If you would like to follow along with hands-on examples, check the description for the link to the GitHub repo. Now, let's get started. Correlation is a statistical measure that indicates the extent to which two variables are linearly related. It shows how changes in one variable correspond to changes in another. In simple terms, correlation tells us whether and how strongly two variables are connected, helping us understand the relationship between them. The value range of correlation coefficient lies between -1 and 1. There are three types of correlation based on its value. Positive correlation, when the value is bigger than 0. As one variable increases, so does the other. Example, height and weight. Negative correlation, the value is less than 0. As one variable increases, the other decreases. Example, amount of exercise and body fat percentage. No correlation, value 0. The variables show no clear linear relationship. Example, shoe size and IQ. In this graph, we see several sets of XY points, with the correlation coefficient of X and Y for each set. The correlation reflects the strength and the direction of a linear relationship, as you see in the top row. But it's not used to reflect non-linearity, as you see in the last row, where the correlation value is 0, while clearly the variables are not independent. Those are examples of non-linear relationships. Correlation is used heavily in time series analysis. For example, in finance, to evaluate how two assets move in relation to each other, helping investors to diversify their portfolios. In marketing, understanding the relationship between advertising spend and sales performance. The formula for correlation is as the following. It can be expressed as the covariance of two variables, x and y, divided by the product of their standard deviations. This highlights the relationship between correlation, covariance, variance, and standard deviation. In Python, you can easily compute the standard correlation coefficient for every pair of attributes using the cor function. Here is an example to illustrate this. You can find the full example in the attached notebook. Covariance we introduced in the last episode, and correlation are very similar concepts. So, what is the main difference between them? Both covariance and correlation measure the relationship and the dependency between two variables. Covariance indicates the direction of the linear relationship. Correlation measures both the direction and strength of a linear dependence between two variables. Covariance values are not standardized. It depends on the unit of the variables, which makes it harder to interpret directly. Correlation values are standardized. So the key difference is scaling. While covariance is raw and unbound, the correlation standardizes this relationship, making it easier to compare across datasets or variables. That's it for today. In the next episode, we will dive into two key statistical functions used in time series analysis, autocorrelation function and partial autocorrelation function. Stay tuned and see you in the next episode. Salam.